All right, so what I'd like to talk about now is object-oriented programming. Has anyone here heard of this phrase before, object-oriented programming? Great. Does someone want to take a stab at defining it? That's okay. So object-oriented programming is a design paradigm that is very common in coding, though not universal. Python is a very strong example of what's called an object-oriented programming language, because everything in it, from a string to an integer to hashes and arrays, is considered an object. Does anyone want to have an idea of what I mean by an object in this case? So
Uh,
in Python,
Structure of stories that you define.
sorry, could you repeat that? I kind of heard a few people talking at once.
It's like your own data structure that you define. You have properties and methods to it, and you can interact with it.
Yes, so an object is a type of data structure. And a data structure, in this case, this data structure can have attributes, kind of like a dictionary or a dictionary and object in JavaScript. It can also have methods. It has its own methods. So one way I like to think of objects is as nouns. So, and by mean nouns, I mean like literally real world objects like computer, cup, car, dog. They all have attributes, adjectives, things that describe them, and methods, things that they can do. So imagine, for example, you've got a dog. Every dog has attributes, things you would use to describe the dog, like its breed, its weight, its color. And they also have methods or actions that they can do, sit, stay, fetch, roll over. And kind of the way that we keep track of what type of object we're using is by making use of classes. So we've used the class keyword before when we were making our unit tests, right? So whenever we made our unit tests, we created a class and then gave it methods. And so we're going to be doing something similar now. So if there's kind of one thing I want you to take away from this lecture, like literally everything else you can figure out, but this is the most important thing, is there are classes and there are objects. A class, think of it like a blueprint. When you write a class, you're saying, okay, I'm creating a blueprint to tell you how to make a dog, a car, a test suite. And every time you create one of those, you're making an instance of that class. So essentially, I'll have a dog class and dog instances. And they are related to one another, but they are distinct. And we're going to get more into that and kind of demonstrate. I'm going to demonstrate how that relationship works. But just remember, as we're going through this, class is the blueprint, and instances or objects are what we use that blueprint to make. And I want to kind of demonstrate a little bit about when I say everything in Python is an object. So let's say I make a string. I'll call it string equals string. And if I write help on string, it gives me a lot of things about it. So it gives me a name, a module reference, description. It gives me a lot of information. We also have something here called classes. So this is actually made up of many different classes that it inherits from. So something called template. It's got functions. So if I want to actually see what the class is of a object, I think it's type of string. It gives me class str. So strings are an object. This string is an object. And str is its class that that essentially said, okay, here's how you create a string object and defines everything a string can do in Python. And I can do the same thing for, type gives me class integer. Or if I do type like so, the class is list. And we can even take this a step further. We could say, I want the type of this type. So the class of it is type. So whenever we're working with Python, everything we're using is a string, and that's how it's organized. What questions do you have about object-oriented programming so far?
So a different type of breed of dog would be like a different instance. That's what you're talking about when you're talking about instances?
Yes, it could be. And we're actually going to kind of talk about that right now. I'm going to make it, whenever I see OOP, I'm talking about object-oriented programming. So let's make a dog class. And the way we do that is just simply by writing the word class and then our name of it. What the heck? This thing tries to be helpful so hard. So we've got a dog class. And I'm going to create a new dog object by writing dog equals dog. And so kind of the convention, what the heck? Okay, that's weird. So the convention for classes is that classes are capitalized. So you kind of, and so we say this dog is a new object of class dog. So if I run Python OOP.py, or I need to, okay, did not open in the right place. One sec.
Don't you need to inherit objects?
Say again?
Do you need to inherit objects?
What do you mean by inherit objects in this case?
That's a Python 2 thing. Python 3,
okay.
It's already implicitly, it already happens.
Yeah. So yeah, in Python 3, like in Python, early versions of Python, we needed to specify that our dog class object inherited from the larger Python object class. In Python 3, they just decided to make that implicit.
Okay,
We'll
but
talk
on
more
line
about it.
4, on the instantiation, do you need to have open and close parentheses?
Good question. Let's test that out. So I do Python OOP.py, no errors. And if I add, oops, what the heck? Add the parentheses, still no errors. So in this particular case, we can do it without the parentheses because our dog object, our dog class is very boring. We've created a dog object. There's not really much to it. Like I can print out dog, and it tells me right here, it gives me this thing. So it says underscore main.dog. And from now on, whenever I see these things, I'm going to call it dunder. So I'll say dunder main dot dog object at 0x10, things like that. Let's unpack this a little bit. So first off, what do you think we mean by dunder main here? Any guesses?
That gets assigned the name of the file, the calling file. So dunder main should be equal to oop.py.
Mm-hmm. Yeah. So dunder main is essentially just a way of saying this is running from a Python file, this particular Python file. Then we say, so in dunder main, we've got a dog object. We've kind of unpacked that a bit. Dog, in this case, let's give him a name like Fido. Fido is a dog object. But then we have at, and then this random string of characters here. What do you think that 0x1062, etc. is?
Isn't it the memory location or something?
Exactly. So what this is saying is our object is stored in memory at this location, 0x1062. But right now, our dog object can't really do much because we haven't given it any attributes and we haven't given it any behaviors. So let's modify this class a bit to actually give it some cool things. So what do dogs typically have?
Legs?
Yeah, legs, usually 4. Eyes, usually 2. a tail, something
Color.
like that.
Sometimes 0.
Sometimes 0. But for now, we're talking about generalities in this
Yeah.
case. So I've given my dog class some attributes now, legs, eyes, and a tail. And to access these, I should just be able to say Fido.legs. And I get 4. So Fido now has an attribute called legs that I can call on by saying .legs. But I don't want to have to do all that work just to find out how many legs, eyes, and tails it has. So I'm going to write a method for this. So I'm going to say def, and I'm going to call this display info. And whenever we're working with classes, every method you write always takes self as an argument. You don't have to pass in self when you call on these methods, but when you define them, you need to say that it has to take self as an argument. And kind of, I'm just curious, based on just generally like what would, by context, what do you think self means in this case?
This in other languages, correct?
It's very
That's the
similar to
this.
this in JavaScript. That's right.
It's referring to like that particular instance.
Yeah. So in this case, self refers to this particular instance of dog, the dog that is calling this method. And I can actually even, say print self. Let's see what happens when I say, okay, I got Fido, and I'm going to write Fido.displayInfo. Let's see what comes out as self. Main dog object at 0x10 FBBB. So the important thing to remember at self is that self's meaning can change depending on where it is in the program. So in this case, we've created what's called an instance method. This method belongs to every instance of dog can call on this method. And by that definition, self refers to whichever dog object is calling on this method. And we'll see later on that self can be used in other ways as well. But regardless, whenever you create an instance method for a class, it always needs to take self as an argument. So now let's actually have this, print out something. So we can say print. So like dogs have, so I could say self.legs, legs, because I'm saying this dog's legs. Self.eyes, eyes, and self.tail, tails. So now if I run this, I get dogs have 4 legs, 2 eyes, and 1 tails. 1 tail. So if I didn't have self here, what do you think would happen?
It would break because it doesn't have the legs variable.
Exactly. So if I just said dogs have legs, legs, it says right here, error, name legs is not defined. It doesn't know where to look for this variable. So I'm saying, look at self, look at this particular dog. All right. So far we've created 1 dog object, but we can create as many as we want. So, I don't know, what's a good dog name? Lassie equals dog. I could say lassie.displayInfo. And in this case, it comes out the same because, we've already said dogs have 4 legs, 2 eyes, 1 tail. So right now, all of our dog objects are essentially identical because we haven't created any way to differentiate these particular instances of dog, Fido from Lassie. So I remember someone asked earlier, okay, do we have to have parentheses? And the answer is, if we don't have any arguments, if we don't have any parameters, then no. But sometimes we want to actually have parameters because maybe we want each of our dog objects to have information that is unique only to it, like, a name, a breed, fur color, stuff like that. So to do that, I'm going to be making use of one of these Dunder methods that we've been talking about. So we call them Dunder methods because it's Dunder double underscore Dunder. And whenever you see a Dunder method, what that usually means is we're taking a method that's actually already built into this class, and we're going to be overwriting it a bit. In this case, I'm going to be making use of a method called Dunder Init. And actually, if you say here, my thing is already showing me, these are all things kind of built into the Python object library, essentially. But I'm going to be grabbing this init method, which automatically runs whenever we create a new instance of dog, and I'm going to be adding some extra behavior to it. So it has to take self as an argument, but then we can also give it name, breed, and color. And so in order to save these parameters to a particular dog object, I want to say self.name is equal to name, self.breed is equal to breed, and self.color is equal to color. And so what these statements say is, all right, this particular dog object has an attribute called name, which is going to be equal to this parameter. So now you can see here, dog, no value for argument name in constructor, no argument breed in constructor. So now I actually need to give all of these dogs arguments. So I could say, Fido. Fido is a terrier who is brown. And then Lassie is a collie who is red. I don't know. And so I'm going to edit my display info thing to, instead of talking about, okay, how many legs dogs have, I want every dog to introduce themselves, tell us their name and breed and color. So I'm going to say, like, hi, my name is self.name. I'm a, oops. Okay, let's make self.breed, and my fur is self.color. So now, if I run this again, hi, my name is Fido, I'm a terrier and my fur is brown. Hi, my name is Lassie, I'm a collie and my fur is red. So each of these are not, these objects don't share this info. Each object is kind of self-contained, and it only has its own attributes. It doesn't have anything else. And it doesn't, besides this stuff. These right here, since we didn't create them in the init section, are what are called class variables. They're shared between all of them. So I'm seeing a bunch of things in chat, making sure I'm not missing any questions. Yeah, so every instance function always needs self as the first argument. And you never actually have to pass self to it. It does that automatically. So I'm just going to take a quick break, quick pause right there. What questions do you have about this creating an instance with its own attributes and functions?
If we want to create an instance, we need the init function.
So you can create an instance without the init function, but then you won't be able to pass any parameters to it. But if you want to pass parameters to a new instance, you need this init function. And init literally is just whatever runs whenever you create a new object. So I can do print creating a new dog. And if I run this code, creating a new dog, and then it runs the function. Because as soon as this runs, it runs the init function, whether we write it or not.
So the stuff that we defined in the dog class in the beginning, that's still the same, like the leg, tail, and eyes and stuff like that. But then
Yep.
we're adding additional information.
Yep,
to
that's still
the
there.
specific one.
Yep, so I can still say, I have self.legs, legs. In this case, since we didn't put this in the init function, every dog object has access to these variables. So now, so they all have access to the legs, self.legs.
So also the self would be like a private variable versus a public. Is that more what it's like?
So the self keyword doesn't have anything to do whether or not the variable is private or public. It's just a way of telling this function right here, hey, when I call on variables either saved here or here, I'm calling on things from this object, self. And actually, since these variables are saved in the dog class, self.legs works. I could also write it as dog.legs, like the dog class, and it should still work.
If you wanted to, sorry.
Go ahead.
If you wanted to change the number of legs, would you have to put it in the init function?
So if we did, well, let's try that. So I'm going to say it takes legs. And I'm curious to see what happens if I do self.legs equals legs. We may have some issues here because there's already a variable defined called legs. And let's see what happens now. So if I do, all right, Fido has 4 legs, but Lassie has 3. I want to try something. All right, so we didn't get any errors. And then I want to try this. So I'm going to say Fido.legs. Oh, I got to print it. Okay. So it looks like, in that case, the legs variable up here did not get overwritten when we created this new dog. So
you want to check Lassie, it did get overwritten.
yeah, well, let's try this. I want to print the dog class legs variable. Okay, so this variable here remains 4, even when we say here, when we create Lassie, self.legs equals 3.
No, you checked the wrong one. Lassie's the one that had 3.
Yeah, but what I was worried about that might happen is that what if by saying Lassie.legs equals 3, that would overwrite Fido's legs.
I got it.
But it looks like that didn't happen. It looks like it's smart. Yeah, it looks like it's smart enough to say, okay, the instance has something called legs, and then the class is something called legs, and we're keeping those separate. But then we get to self.legs, and I think it defaults to the instance instead of the class. So in general, I might want to say, okay, to avoid issues like that, I'd probably want to make sure that we don't have any class variables and instance variables that have the same name, because that way we can make sure that nothing goes wrong. We could say something like, giving it a default value, like legs equals 4, and then us not having legs be a variable up here. It's a good question, though. So I'm going to kind of move on to a new example, because dog information is doesn't really apply to many things. And in general, kind of the idea behind object-oriented programming is that we want to have every class should be emulating either a real-world object or something that kind of can exist within our program. So for example, let's try another example. Let's say that we have been hired to create a system for a company to keep track of employee information. To do that, we may want to make a class called employee. And let's make an init method. And what kind of information would we want to save about an employee?
First and last name.
Yeah, first name and last name. Maybe their salary.
Gender, or maybe employee number.
Yeah, you can do like gender and ID.
ID.
And then we'd have to say self.first. We have to, kind of repeat all of this. Self.first name equals first name. Self.last name equals last name. Self.salary. salary equals salary. Self.gender equals gender. And self.id equals ID. All right, so now we've got some things here. And one thing I also want to emphasize is we don't have to have, like, everything we define here doesn't have to be just assigning things from here. We could also create an email, so like self.email equals, and then we could, you know, define it by as first name dot last name at company.com. So this is just a regular function, and we typically use it to do this assigning of instance variables, but we can also do other things like creating our own instance variables that don't come directly from the user. And I'm also going to create some class variables. Remember, class variables, they're shared between every instance of the class. They all have access to them. So I want to say, for example, number of employees. So in this case, I'm saying the employee class as a whole is going to have access to a variable called number of employees. And I'll also do something like raise rate, like how much you can get as a raise. And I'll say you get a 1.12 rate. So whenever you get a raise, you multiply your salary by 1.12. We should all be so lucky. And so again, so now I have this number of employees variable. And now I should be able to say, okay, whenever I create a new employee, I should increase that number. So I'd want to say employee. And I could use self here, but I like using the class name just because it's more clear about what I'm trying to do. Dot number of employees plus equals 1. So every time we create a new employee, that number should go up. So if I go, let's say Noah equals employee. And also, if you don't want to do things in order with classes, with objects, you can also do something like this. First name equals Noah. Last name equals Heinrich. Salary equals 10. Gender equals F. ID equals random string. And then if I do, so I do that, and then I should be able to say print employee.number of employees. And I should see the number of employees has gone up to 1. Yep. So that's something I've done. I've been able to say, okay, if I can change the number of employees whenever I create a new employee. And I can also create other methods. So I could say, give raise has self. And I want to change the salary to be multiplied by the raise amount. So I could say self.salary equals, you might want to do like self.salary times equals, and I could do self.raise rate or employee.raise rate, and it would still work either way, because essentially whenever you use self and try to do that, it'll first check the instance, and if it can't find that, it'll try the class. But if you want to be more specific, saying I'm calling on the employee class's raise rate function attribute. So I can do that. Now I should be able to say Noah.giveRaise.
I think you want times, not times equal.
Oh,
Because you
yes,
already
thank
made
you.
the assignment.
Noah.giveRaise, and then if I print Noah.salary, I should see that that number has gone up. Yep. So now I'm making $11.20 plus an infinitesimal fraction of a cent. So class variables are very useful because you can share them between classes, but there's also things you may want to be careful of. So I'm going to go back to my dog example for a bit. Comment this out. So let's say I want to be able to teach dogs tricks. I could make a class variable called tricks. And then I could say, you know, make a function called learn trick, which takes in self and trick as an argument. And I could say self.tricks.append trick. So what's the problem if I do it this way? If it's tricks is defined up here. So let's say I, you know, create.
So it's not already in the instance, right?
Yes, so it's not part of the instance, it's part of the class as a whole. So for example, if I do Fido.learnTrick rollover, and then create Lassie as well, and have Lassie learn a different trick, you know, fetch. So if I print Fido's tricks, Fido.tricks, it says here Fido knows rollover and fetch, but I didn't teach fetch to Fido. I only taught Fido how to roll over. Because tricks, the way it's written here, is a class variable. It belongs to the entire, every instance has access to it. So kind of one of the most common mistakes I see a lot of developers make is that they'll create a class variable where it should be an instance variable, and then the classes start messing with each other in ways they shouldn't be able to. The objects, each individual object starts messing with each other in a way they shouldn't be. Because each individual object should only have access to its own information. It shouldn't have access to anything that we don't tell it to share. So I'd want to make sure that here, I would say self.tricks equals an empty array. So by putting it inside this init, I'm making sure that every dog has its own array of tricks that it doesn't share with any other ones. So now if I run it, Fido only knows rollover. Fido doesn't know how to fetch because we only added it to Fido's version of self.tricks.
Oh, hold on a second. Why did that work? Because where did that parameter in your parent class in your Init? I've got breed color, but I don't have tricks.
So in this case, I told init to take 3 parameters, name, breed, and color, and I assigned those here. I can create more class attributes that don't come from parameters if I want to. I can add as many as I want besides things that come from here. I could also say, you know, self.smell equals bad. And that'll just do it without having to take a parameter to tell it to smell bad.
But how do I access it if I don't have a parameter? That's what I'm wondering, right?
So whenever you say self.something equals this, that automatically gives the instance access to it by using that. So even though I didn't add bad as a smell to here, I should be able to say Fido.smell because I defined it inside the function. So Fido smell is bad.
So it's not defined just for the whole class. It's only within the instance, which is part of your init. And it doesn't have to come in as a parameter is what you're saying.
Exactly. So anything we do in this init is added as an attribute, well, can be added as an attribute to this dog. And we can also do other things because init acts just like any other function. It just also has the ability to assign attributes. And those attributes can come from parameters, but they don't have to.
Now, my issue is though, if I instantiate a subclass, I cannot override tricks or smell in that instantiation call. I have to do it later, right?
So yeah,
can't put those parameters in there if I wanted to and override that. I have to do it as a second call. Is that correct?
Yes. So the way it's written now, we can't like when we create it, tricks will automatically be an empty array and smell will automatically be bad. But we can easily reassign it by just doing Fido.smell equals good.
Right, that's what I'm saying. You have to do it as a reassignment. You can't do it in the Lassie equals dog, Lassie color red. It won't accept it.
Yeah, the way it's written now, exactly. But we could change that if we want to. And, you know,
I'm
whether
just
or not,
sure that's, yeah, okay, I got it.
and
Thanks.
whether or not you want, you know, certain things to be done when you, as parameters, and certain things to be done as default values is entirely up to you and depends on the circumstances.
Could you have also put your tricks or assignments within the, like say, smell or whatever into a separate function like you did with the tricks?
Yeah, we could definitely do that. We could also write a function to say you know, clean dog. And maybe we want to say, you know, if dog.smell equals bad, dog, or sorry, not dog, self.smell equals bad, self.smell equals good. So, and sometimes you'll want to make sure that you have methods for reassigning rather than just, you know, just reassigning like this. Because sometimes you don't want the user to know that, like, oh, I can just do this. They should, you know, maybe you want them to go through a function instead. And I don't remember off the top of my head if Python has a built-in way to protect your attributes from the user. Like in Ruby, you actually need to specify whether or not a user has access to attributes. In Python, they're all available by default.
In Python, can you make it as a private class or no?
A private class?
I thought you typically prepending it by underscore is supposed to tell the user it's private, but you could still access it if you want.
Yeah, yeah. In Python, everything is public, and then they kind of follow like they kind of say we're all adults here, so you'll prefix an underscore if you don't want the developer to access that attribute instance directly. You want to use it within the class itself, like referencing self within a method, but you don't want to access it directly when like at the bottom when Noah's doing like when you're talking to the dog instance. I'm trying to find an example on the screen somewhere on the bottom, like when Noah says Lassie dot and then you're trying to access the private attribute. You don't want to do dot underscore and then the private attribute, because then you're directly accessing it and you're kind of violating the convention for it.
Yeah, and this will be something you get more into as you continue. For now, your classes, like, you don't need to worry too much about protecting your attributes. But as you move forward and create more complex programs, you may want to say, all right, I want to make sure that I'm only having as much information as my user will need and nothing more. And like, if there's other things that they may have access to, I want to just essentially say, this is working in the background. You don't need to access it. You don't need to change it. And that's more of a design principle that we'll get into later, as like I said. Yeah, and it's considered good practice to create functions to change attributes rather than just allowing users to change them whenever they want, just because it's cleaner and gives you more control over exactly how they do it. Like I remember when you talk about making sure you're sanitizing your inputs, you don't want to be able to say, okay, if I want to say, all right, a dog can't, or let's go back to our employee example for something a little more concrete. A user shouldn't be able to just say, all right, Noah.salary equals 1 billion. You got to access a function that gives the programmer control over how much money she can give herself.
Haven't I seen Python code where they do the check if name is not equal to main, then get out? Something along those lines.
You mean like if name? if Dunder name.
If Dunder name is not equal to main or
Yeah. So
something like that.
yeah, so we can talk about that real quick. So we do that. You may have noticed we add that to all our unit tests. If Dunder name equals Dunder main, like this. And the reason we do this is whenever you import a file from to another file, that file automatically gets run. So if I had a spec file here that imported oop.py, as part of the importing process, everything on this page would get run, including all my print statements and everything like that. And so when and the way it does that is, let's see if I can actually do this right here. If I can do print. I hate when that happens. All right. So we printed name and we got main. And if name equals main, that means we're running this file directly by running python oop.py. But we want to, if we said if name wasn't main, that means it's being imported and we wouldn't want it to, we'd want it to do something or not do something. That's why in our spec files, we say if name equals main, do unit test.main. Because we're saying, I only want to run this unit test if we're calling on it directly. If it's being imported, don't run it. So that's just a way of protecting your files and making sure they only do what you want them to do. So for example, here, I'd probably want to take all of this code and put it in my if name equals main. Let's see if I can make this work. Oops. Ah. So
Yeah.
I've got all my runner code here.
Yeah, that's what I thought I had seen before. And I thought I had seen that inside of classes too, to do a public-private check, but I don't know.
Yeah, I'm not sure, but I'd still like to demonstrate this real quick. So I'm going to make, touch, let's call this OOP spec.py, even though we're not actually doing a spec file. Okay. Where's my file explorer? So I did, from OOP import dog. And all right, so if I run Python OOP spec, nothing happens. If I took out that, if I take this out, the if name equals main, got to make sure everything's unindented. Then if I run it again, we created a dog. All of this runner code happened because we didn't have that if underscore dunder name equals dunder main. All right. So any other questions about object-oriented programming?
In terms of all the class stuff, should we know all of this in terms of doing it in JavaScript as well?
So JavaScript is not an object-oriented language per se. It can do object-oriented stuff, and we'll get into that. But for this week and kind of the foreseeable future, you only need to worry about object-oriented programming in Python. JavaScript is considered a functional language. Everything is a function rather than an object. And because people like to make JavaScript do everything, even things that probably shouldn't, people found a way to make JavaScript do object-oriented programming, but Python is more built for it. So all of the challenges this week, I believe, that involve object-oriented programming are only going to be Python. Any other questions? In that case,
Can you hear me?
yes,
Sorry,
I can hear you now.
my button was muted. I was trying to ask you a question. When you organize your classes, because the programs are going to become more complex, do you save them in individual files, or how do you organize them?
Good question. Yeah, so not just with classes, but in general, the larger and more complicated your program is, the more likely you are going to ship things off to different files. And as we're going to see when we get into Django, a lot of your models may or may not live in their own files. It often depends, but it's not uncommon to see each class having its own file. Cool. Any other questions before we end for the day, or end for the morning, I should say? All right. So in that case, let's see here. So it's 11:18 now. So this was our last lecture for the day. You've got 2 challenges to do today: guessing game and Boggle. Those are both going to be done using object-oriented principles. And there's also a stretch goal of Boggle Part 2. So by the end of the day, you should be try to finish guessing game and Boggle Part 2 if you've got time and energy and you feel like you want more of a challenge. Otherwise, feel free to take a break. You can take a lunch break now or wait till 12. And then take the rest of the afternoon for the challenges. And Tom and I will be here for any questions you may have. And I'm going to hop off the call so I can upload the videos and the code and everything like that.
Thanks, Noah.
No problem.